Hello everybody, thank you for watching. This is our 2.6 video, how to calculate average atomic mass. The objectives for this video is how to learn how to calculate average atomic mass of atoms using isotope masses and percent abundance. So the first thing you want to kind of notice is when you're looking on the periodic table, you want to ask yourself, why are all these decimals present right over here? So these decimals are just elements of just mixtures of isotopes. So if you take a look at this picture of this banana, this is potassium. So these are the common isotopes of potassium. You can see 93% of the isotope of potassium comes from this isotope. 6.73% comes from potassium 41, and then very little comes from potassium 40. If you take a look at the mass of potassium on the periodic table, you're going to see that it actually resembles somewhere around 39 because most of this percentage of these isotopes come from this type of isotope. When it's averaged together, that number is going to be closer to 39. So the big idea really is that the atomic mass is just a weighted average of all the isotopes of that specific element. So when you take a look at the periodic table, this is an example of chlorine now. These are two isotopes. We want to ask ourselves which isotope makes up more of the atomic mass of chlorine. So chlorine 35, we have 76% of those in nature. And chlorine 37, we have 24% of that. So what really is the mass of chlorine is somewhere near 35. So chlorine 35, since it's more abundant, there's more of these isotopes in nature, it is going to make up most of the mass of this chlorine that we average on the periodic table. So the key point is here. Percent abundance, what it does is it shows how common or abundant each isotope is. There actually is a mathematical way of calculating average atomic mass. So if we know the percent abundance and the mass of isotopes of any element, we can calculate using this average atomic mass formula. So this is the formula. If you take the first isotope and multiply the mass and percent abundance together and add that with the second isotope, this is considered taking the weighted average. So you're going to follow this formula when you're doing any average atomic mass problems. So let's do an example problem. So this problem says boron has two naturally occurring isotopes, boron 10 with a percent abundance of 19.8% and boron 11 with a percent abundance of 80.2%. We want to calculate the average atomic mass of boron. Note that this is the formula right here. So we're going to take our first isotope, which is boron 10, and we know that the percent abundance is listed right over here. When you're adding percentages to a formula, you have to remember you always want to change them to a decimal. So our percent abundance now is 0.198, right? Our second isotope, boron 11, has a percent abundance of 80.2. So if we change that to decimal, it's going to be 0.802. You want to follow this formula and multiply both of them together. When you do that, you're going to see that we have 1.98 as this answer and 8.822 for this answer. So these are kind of your sub answers. The last part is to just add all of these isotopes together. So when you do that, you're going to get a total average atomic mass of 10.02. And if you look on the periodic table, this is a very similar mass of boron. Our next example problem right here, I want you to pause the video and try this one yourself, and then come back and see if you get the right answer. So for this problem, we want to calculate the average mass of an unknown isotope. We don't know what it really is, but we know that if it has a 60.4% of the atoms have that mass of this, which is 68.9, and the rest of the mass is 70.9. So we want to kind of write that in the form that we usually write it. So our unknown isotope number 1, it has a mass of 68.9 and a percent abundance of 60 0.4, which we want to change to a decimal, like that. We know all percentages are out of 100. So when it says the rest of the isotope has a mass of this, that means we have to take 100 minus the percent abundance that we already have. So if we take 100 and minus 60.5, the second isotope is going to have a percent abundance of 39.4%. So our second isotope, we know it has a mass of 70.9 AMU, and now it has a percent abundance of 39.4. So if we change that to a decimal, we get something that looks like this. You want to go ahead and multiply these together. When we do that, the first sub answer that we get is 41.61. The second one would be 28.07. Right? The last step is to just add all of these masses and abundances together, and you get a final answer of 69.68. The last part of this problem says identify the element in the periodic table. So you want to look on the periodic table and see what mass does this match or is the closest to. And when you do that, you're going to see that gallium is that element that it matches. So in this video, we talked about these 3 key ideas. One thing you do want to remember is always change your percent abundance to a decimal before you add it to your formula. Thank you for watching.